Welcome to Math Contest Drills for Filipino Kids. Let us discuss the solution to 2015 MMC Elimination Round for Grade 9. And this will be part 1 of 2 parts, numbers 1 to 25. Let us have the instruction. Give all fractions in lowest terms and all equations of lines in the form ax plus by equals c, where a, b, and c are relatively prime integers with a greater than 0. Question number 1. Simplify square root of 3 halves minus square root of 2 thirds. For our solution, let us rewrite the radicals. Square root of 3 over square root of 2 minus square root of 2 over square root of 3. Then we can subtract by getting the LCD, that is square root of 2 times square root of 3. We divide square root of 2 times square root of 3 by square root of 2. The answer is square root of 3 times square root of 3. That will be 3 minus. Also, we divide square root of 2 times square root of 3 by square root of 3, and that is square root of 2 times square root of 2. That will be equal to 2. Now we have 1 over square root of 6. Rationalizing the denominator, we multiply each of the numerator and denominator by square root of 6. Hence, our final answer will be square root of 6 over 6. Number 2. Evaluate 2 raised to 0 plus 2 raised to negative 1 over 2 raised to negative 2 plus 2 raised to negative 3. We can rewrite the given using the rules of exponent. 2 raised to 0 is equal to 1. 2 raised to negative 1 is 1 half. In the denominator, 2 raised to negative 2 is 1 over 2 squared, or 1/4. 2 raised to negative 3 is 1 over 2 raised to 3, or 1/8. Then we can add the terms in the numerator and in the denominator. So 1 plus 1 half is 3 halves. In the denominator, the LCD is 8. So we have 8 divided by 4 is 2 times 1. So that will be 2 plus 1. So we have 3 halves over 3/8. Now we have division of fractions. We can have this as 3 halves times the reciprocal of the denominator, that is 8 over 3. 3 divided by 3 is 1, so we have 8 divided by 2. The answer is 4. Number 3. Simplify square root of 1/9 plus 1 over 16. We can start by adding the fractions inside the radical symbol. Our LCD is 9 times 16, that is 144. 144 divided by 9 is 16 times 1. We have 16. For the second term, we have 144 divided by 16, that is 9, times 1, that is 9. So we have square root of 25 over 144. Both the numerator and denominator are perfect squares. So we have square root of 25 is 5. The square root of 144 is 12. So the answer is 5 over 12. Number 4. Simplify x raised to negative 1 minus y raised to negative 1 over x raised to 1/3 minus y raised to 1/3. Let us simplify the numerator by rewriting x raised to negative 1 as 1 over x and y raised to negative 1 as 1 over y over x raised to 1/3 minus y raised to 1/3. Subtracting the numerator or the terms in the numerator, we now have y minus x over xy over x raised to 1/3 minus y raised to 1/3. Now we can rewrite this as negative of x minus y over xy times 1 over x raised to 1/3 minus y raised to 1/3. We can get rid of terms with fractional exponents in the denominator by multiplying both numerator and denominator by x raised to 2/3 plus x raised to 1/3 y raised to 1/3 plus y raised to 2/3. Now we have negative of x minus y over xy times x raised to 2/3 plus x raised to 1/3 y raised to 1/3 plus y raised to 2/3. The product x raised to 1/3 minus y raised to 1/3 times x raised to 2/3 plus x raised to 1/3 y raised to 1/3 plus y raised to 2/3 is the special product of a binomial and trinomial whose product is x minus y. That is x raised to 1/3 cubed minus y raised to 1/3 cubed. Now we can divide x minus y over x minus y as equal to 1. Hence, our final answer is the negative of x raised to 2/3 plus x raised to 1/3 y raised to 1/3 plus y raised to 2/3 all over xy. Question number 5. If a, b, and c are real numbers such that b over a equals 5 and b over c equals 2, what is the value of a plus b over b plus c? From b over a equals 5, we can have b is equal to 5a. Adding a to both sides of this resulting equation, we have a plus b equals 6a. Also, we have b over c is equal to 2. Then we have b is equal to 2c. Adding c to both sides of this equation, we have b plus c is equal to 3c. Hence, we have a plus b over b plus c is equal to 6a over 3c. And that is 2a over c. Now, from b over a equals 5, we can have a over b is equal to 1/5. If we multiply this equation by bc equals 2 term-wise, we can have b over c times a over b is equal to 1/5 times 2. b over b is equal to 1. A over c is equal to 2/5. Substituting a over c equals 2/5 to 2a over c, that will be equal to 2 times 2 over 5. Hence, a plus b over b plus c is equal to 4/5. Number 6. If x is not equal to 0, x over 9 is equal to y squared, and x over 3 is equal to 3y. What is the value of x? From x over 3 is equal to 3y, dividing both sides by 3, we'll have y is equal to x over 9. And substituting y equals x over 9 to x over 9 equals y squared, we'll have x over 9 equals x over 9 squared. And this will be x over 9 is equal to x squared over 81. Multiplying both sides by 81, we'll have 9x is equal to x squared. Subtracting x squared from both sides, we'll have 9x minus x squared is equal to 0. By factoring, we have x times the quantity 9 minus x equals 0. By zero property of multiplication, we'll have x equals 0 or 9 minus x equals 0. Adding x to both sides, we'll have x is equal to 9. And since x is not equal to 0, we have x is equal to 9. Number 7. If f of x is equal to x squared plus 6x plus 9, what is f of x minus 3? From evaluation of function, f of x minus 3 means substituting x minus 3 to all x in the original function f of x. And that will be x minus 3 squared plus 6 times x minus 3 plus 9. Square of binomials, we have x squared minus 6x plus 9. Distributive property, we have 6x minus 18 plus 9. We have x squared, negative 6x plus 6x is 0. 9 minus 18 is negative 9 plus 9, that is 0. Hence, f of x minus 3 is equal to x squared. Number 8. If f of x is equal to x squared plus 1 and g of x is equal to x minus 1 for all real number x, for what real numbers does f of g of negative a equals g of f of negative a? Let us have g of negative a, and that will be equal to negative of a minus 1. Also, let us have f of negative a, and that will be negative a squared plus 1, and that is a squared plus 1. Next, let us have f of g of negative a, and that will be negative a minus 1 squared plus 1. And this is a squared plus 2a plus 1 plus 1, or a squared plus 2a plus 2. Next, let us have g of f of negative a, and that will be a squared plus 1 minus 1, and that is a squared. Therefore, we have f of g of negative a equals g of f of negative a. That will be a squared plus 2a plus 2 equals a squared. Subtract a squared from both sides, we have 2a plus 2 equals 0. Subtract 2 from both sides, we have 2a equals negative 2. And then dividing both sides of this resulting equation by 2, we have a equals negative 1. Question number 9. Solve for x in square root of 3 plus square root of x equals 3. Squaring both sides of this equation, we'll have 3 plus the square root of x equals 9. Subtracting 3 from both sides, we'll have the square root of x is equal to 6. Squaring both sides of this resulting equation, we have x is equal to 36. Number 10. Solve for x in the equation 2x over x plus 2 plus x plus 2 over 2x equals 2. Multiplying all terms of the equation by the LCD of the fractional term, that is 2x times x plus 2. In the first term, x plus 2 cancels, so we have 4x squared. In the second term, 2x cancels, so we have x plus 2 squared, that is x squared plus 4x plus 4. In the right side of the equation, we have 4x squared, that's 2 times 2x times x, plus 8x, that is 2 times 2x times 2. Subtracting 4x squared from both sides of the equation, also subtracting 8x, we will have x squared minus 4x plus 4 is equal to 0. X squared minus 4x plus 4 can be factored as x minus 2 squared equals 0. Therefore, x is equal to 2. Number 11. If x is not equal to 1, solve for x in 2 square root of x plus 3 over square root of x equals 5. Multiplying all terms of this equation by square root of x, we'll have 2x plus 3 equals 5 square root of x. Squaring both sides of the resulting equation, then we have 4x squared plus 12x plus 9 equals 25x. Subtracting 25x from both sides, we'll have 4x squared minus 13x plus 9 equals 0. Then we can solve for x by factoring the quadratic trinomial. We have 4x minus 9 times x minus 1 equals 0. Equating both factors to 0, we have 4x minus 9 equals 0 and x minus 1 equals 0. From the first factor, we can get x is equal to 9 over 4, and on the second factor, we can get x is equal to 1. And since x is not equal to 1, the answer is 9 over 4. Question number 12. Evaluate square root of 2 plus 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 ... Let x be equal to the given expression square root of 2 plus 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 ... Squaring both sides, will have x squared is equal to 2 plus square root of 2 plus square root of 2 plus square root of 2 plus dot dot dot. Notice that the second term in the right hand side of the equation is still equal to x as we assumed in the first equation. So we have x squared is equal to 2 plus x. Subtracting 2 plus x from both sides of this resulting equation, we have x squared minus x minus 2 equals 0. Now we can solve for x by factoring. We have x minus 2 times x plus 1 equals 0. Equating both factors to 0 by the zero property of multiplication, we have x minus 2 equals 0 and x plus 1 equals 0. Adding 2 to both sides of x minus 2 equals 0, we have x is equal to 2. And then subtracting 1 from both sides of x plus 1 equals 0, we have x equals negative 1. Since the expression square root of a number cannot be a negative value, hence we do not have x is equal to negative 1 for an answer, then we have x is equal to 2, or the expression is equal to 2. Number 13, find two consecutive positive integers whose product is 506. Let us use the continuous division to get the prime factorization of 506, but let us stop when we already have two positive integers whose product is 506. 506 can be divided by 2, so we have 2, 5, 3. 253 can be divided by 11 since 2 plus 3 is equal to 5. 25 divided by 11 is 2. So we have 2 times 11, 22. 25 minus 22 is 3. Then we have 33 divided by 11, that is 3. Since 2 times 11 is equal to 22, then our answer is 22 and 23. Number 14. If c is greater than a greater than 0, and if a minus b plus c equals 0, find the larger root of ax squared plus bx plus c equals 0. Using the quadratic formula to get the roots of ax squared plus bx plus c equals 0, we have x is equal to negative of b plus minus the square root of b squared minus 4ac all over 2a. Also, from a minus b plus c equals 0, we can get b is equal to a plus c. Then substituting a plus c equals b in the quadratic formula, we have x is equal to negative of a plus c plus minus the square root of a plus c squared minus 4ac all over 2a. A plus c squared is a squared plus 2ac plus c squared. Then we have minus 4ac over 2a. Simplifying the expression inside the radical symbol, we have x is equal to negative of a plus c plus minus square root of a squared. 2ac minus 4ac is negative 2ac plus c squared all over 2a. A squared minus 2ac plus c squared is a perfect square trinomial. Then we have negative of a plus c plus minus a minus c all over 2a. So we have the two values for x, which are the two roots of the given quadratic equation. X is equal to negative a minus c plus a minus c over 2a, and the other root as negative a minus c minus a plus c over 2a. Negative a plus a is 0, so we have x is equal to negative 2c over 2a, that is negative c over a. For the other root, negative c plus c is 0, so we have negative a minus a, that's negative 2a over 2a, and that is negative 1. Since c is greater than a, greater than 0, we have c over a as greater than 1. Hence, negative c over a is a value that is less than negative 1. Therefore, the larger root of the given quadratic equation is negative 1. Number 15. Solve for x in 2x squared plus x is less than 6. Subtracting 6 from both sides of this inequality, we have 2x squared plus x minus 6 is less than 0. Factoring the quadratic trinomial on the left-hand side of the inequality, we have 2x minus 3 times x plus 2 is less than 0. The roots of the quadratic equation 2x minus 3 times x plus 2 equals 0 are negative 2 and positive 3/2. Hence, the solution to the inequality are all values of x greater than negative 2 but less than 3/2. Number 16. Solve for real numbers x satisfying the inequality x minus 2 square root of x is less than or equal to 3. From the second term in the inequality, 2 square root of x, we know that x is greater than or equal to 0. Subtracting 3 from both sides of the given inequality, we have x minus 2 square root of x minus 3 is less than or equal to 0. You can factor this trinomial as the square root of x minus 3 times the quantity square root of x plus 1 less than or equal to 0. Equating factors to 0, we have square root of x minus 3 equals 0. Then we have square root of x equals 3. Then x is equal to 9. While on the other factor, we don't have a solution. Since square root of x plus 1 is equal to 0, will yield square root of x equal to negative 1. There is no real number x whose square root is negative 1. Therefore, the solution to the inequality are all values of x greater than or equal to 0 but less than or equal to 9. Number 17. Find the minimum value of x squared minus 8x plus 3. Let y be a function of x, that is x squared minus 8x plus 3. Then we have y is equal to x squared minus 8x plus 16 plus 3 minus 16, completing the square in x squared minus 8x. Hence, we have y is equal to x minus 4 squared minus 13. This is an equation of a parabola in standard form with vertex at 4, negative 13. Hence, the minimum value of x squared minus 8x plus 3 is negative 13 when x is equal to 4. Number 18. Find the smallest value of x plus 5 over x for all real number x. Using the AMGM inequality or the arithmetic mean, geometric mean inequality, if a and b are real numbers, the arithmetic mean of a and b is greater than or equal to the geometric mean of a and b. Hence, we have a plus b is greater than or equal to 2 times the square root of ab. If the two numbers are x and 5 over x, then we have x plus 5 over x is greater than or equal to 2 times the square root of x times 5 over x, and that is 2 square root of 5. Therefore, the smallest value of x plus 5 over x is 2 square root of 5. Number 19. Solve for b in the equation x plus 1 times x plus a equals x squared plus bx plus 3. Multiplying the binomials in the left-hand side of the equation, x plus 1 times x plus a, we have x squared plus ax plus x plus a, that is x squared plus bx plus 3. Rewriting the left-hand side of the equation, we have x squared plus 1 plus a x plus a equals x squared plus bx plus 3. Subtracting x squared from both sides of the equation, we leave 1 plus ax plus a equals bx plus 3. Comparing the terms of the left-hand side and right-hand side of the equation, we have a is equal to 3 and 1 plus a is equal to b. Since a is equal to 3, we have b is equal to 1 plus 3 or 4. Number 20. Write the quadratic equation with integer coefficients whose roots are the reciprocal of the roots of 2x squared minus 3x plus 1 equals 0. Let a and b be the roots of this quadratic equation. Then by Vieta's theorem, we have a plus b is equal to 3 halves and ab is equal to 1 half. If a and b are the roots of the given quadratic equation, then the required quadratic equation will have the roots 1 over a and 1 over b. Also, by applying Vieta's theorem, we get the sum of these two roots. We have 1 over a plus 1 over b is equal to a plus b over ab, and this is equal to a plus b is 3 halves, ab is 1 half, then this is equal to 3. The product of these roots, 1 over a times 1 over b is equal to 1 over ab, and that is the reciprocal of AB. That will be equal to 2. Hence, for the required quadratic equation, we have x squared minus 3x plus 2 is equal to 0. Number 21. Compute the sum of all the roots of x minus 2 times x plus 1 plus x minus 1 times x plus 4 is equal to 0. So we have x minus 2 times x plus 1 plus x minus 1 times x plus 4 equals 0. X minus 2 times x plus 1 is x squared minus x minus 2. X minus 1 times x plus 4 is x squared plus 3x minus 4 equals 0. Combining similar terms, we have 2x squared plus 2x minus 6 equals 0. The quadratic equation is of the form ax squared plus bx plus c is equal to 0. By Vieta's theorem, the sum of the roots r sub 1 and r sub 2 is equal to negative of b over a. In the resulting quadratic equation, b is equal to 2 and a is equal to 2, so we have negative of 2 over 2, that is equal to negative 1. Number 22. If r and s are roots of x squared plus x minus 1 equals 0, evaluate r plus s squared. By Vieta's theorem, if r and s are roots of the quadratic equation ax squared plus bx plus c equals 0, then the sum of the roots r plus s is equal to the negative of b over a. In the given quadratic equation, a is equal to 1, b is equal to 1, and c is equal to negative 1. Hence, the sum of the roots r plus s is equal to negative of 1 over 1, and that is equal to negative 1. Squaring both sides, we have r plus s squared is equal to positive 1. Number 23. For what value or values of m are the roots of m minus 1x squared minus mx plus 1 equals 0 equal? From the nature of roots of a quadratic equation, the discriminant b squared minus 4ac is equal to 0 when the quadratic equation has two rational real roots that are equal. Hence, in the given quadratic equation, we have negative m squared minus 4 times m minus 1 times 1 equals 0. M squared minus 4m plus 4 equals 0. Factoring the resulting quadratic trinomial, we have m minus 2 squared equals 0. Then we have m minus 2 equals 0 and m is equal to 2. Number 24. It is known that y varies directly as the square of x, and that y is equal to 8 when x is equal to 1. What is y when x is equal to 8? From the direct variation, we have y is equal to kx squared. We can get the constant of variation by substituting y equals 8 and x equals 1 to this model of variation. Then we have 8 is equal to k times 1 squared, and k is equal to 8. Hence, the equation of variation is equal to y is equal to 8x squared. We can get the value of y substituting x is equal to 8. Y is equal to 8 times 8 squared. Then y is equal to 512. Number 25. Suppose that x and y are inversely proportional and are positive quantities. By what percent does y decrease if x is increased by 25%? If x and y are inversely proportional, then we have y is equal to k over x. Since x is increased by 25%, the variation will be y is equal to k over 1.25x. 1.25 is 5 over 4. Then we have k over 5x over 4. Simplifying, we have y is equal to 4k over 5x, or 4/5 of k over x, and that is y is equal to 0.8 of k over x. That means y is decreased by 20%. Part 2 of this video will be uploaded soon. Thank you for watching. Please subscribe for more math contest drills for Filipino Kids videos.